Welcome to Unit 9, Lesson 4, Laws of Logarithms. In this part of the unit, we're going to look at some laws that apply to log functions that will enable you to solve problems more clearly by either expanding or combining the terms to give you numbers that you can work with. So to start, we have the product law of logarithms. It says the log of a product of numbers can be expressed as the sum of the logs of the numbers. So we have the general formula here, log c m times n is equal to log c m plus log c n. Below here, there's the proof. I'll let you read through it, but basically it shows that mn is equal to c to the power of x plus y, log c of mn is equal to x plus y, and then these terms are all equal to each other. So if you are presented with a logarithm that has multiplication of the two answers, it could look like 2 root 2 or 8 times 6, whatever it is, then you can break it apart into its parts with the same base c. The second law we have is the quotient law of logs. So similar to the one above, we have log c to the m divided by n, and you can simplify that and break it apart into log c of m minus log c of n. So when you see division in that answer part, you can go ahead and expand it to this format. The power law of logarithms. So if we have a logarithmic function written as log c m to the power of p, then this exponent p can become the coefficient in front of your logarithmic function. So you would end up with p times log c m. I just wanted to draw your attention to your formula sheet. If you are unable to remember these log laws, then they're here for you and you're able to not have to memorize them. They're right on your formula sheet, so you can just look for the format that you have and then know how to expand each term. The image on the back is just a continuation of the explanation for why log c m to the power of p is equal to p log c m. You don't necessarily need to understand the proof, but it may help you in applying these laws when you are presented with a problem. So it's just three things: multiplication, division, and exponents. Now that we have these laws, we can use them to expand expressions. So I'll just go over the first example to start with. We have log 5 x times y divided by z. Now remember from the previous page, this is a product rule and this is a division rule, so we'll be adding and subtracting. So you can expand it, log 5 x times y minus log 5z, and then this term can be broken apart further, log 5x plus log 5y minus log 5z. You can read through the explanations of b and c. I'm going to quickly go over d so that you can see kind of how the numbers are moving around. So we have log x to the power of 3 divided by y root z. Now I just wanted to remind you that a square root symbol, that's an exponent of 1/2. So as we break this apart, we'll have the log of x cubed subtract the log of y times root z. And then this term can be further expanded. So if we change the square root z to an exponential form, z to the power of 1/2, it's z to the power of 1, and then take the square root. That's what the fraction means. So we'll have log x cubed minus log y plus log z to the half. And then the last thing you can do is just take these exponents here, 3 and 1/2, and move them to the front of your logarithmic function to complete the question. So 3 log x minus log y minus 1/2 log z. Now that you have the skills to be able to expand the log functions, you can use them to actually solve and evaluate an expression. So I've given you examples here, A, B, C. We'll just start with A and talk about what's kind of involved in solving this question. So notice that the base is the same. It's log 6 for all of them. And what that can simplify down to, so we're adding here 8 log 6 8 plus log 6 9, and then subtracting here log 6 2. So for the 8 plus 9, we're going to apply this product law, and then the divided by 2 comes from this quotient law. So we'll on top have log 6 8 times 9, which is 72, divided by 2. So the answer of that is 36. And we have log 6 to the 6 squared, so x equals 2, or the whole expression equals 2. If you need a reminder about exponential form, remember this log 6 of 6 squared, that would be 6 squared is equal to 6 to the power of x. So of course x and 2 would be equal, and that's why the answer is such. In B, you're just using the product law to break this apart. So you'll have 7 times the root of 7, or 7 times 7 to the 1/2. And then you can just use distributive property and break apart the terms log 7 7 plus log 7 7 to the 1/2. Move the 1/2 to the front, and then just fill in the values. 7 to the power of x equals 7. Of course, it's 1. And then the same thing here, times 1/2. So we would get 1.5 or 3/2. Both are perfectly good answers. In C, it looks a little bit more complicated, but I just want you to remember to use your order of operations. So just resolve your brackets first, and then just carry on and move along. So what we've done in this question is we have started by taking this 1/3 and making it the exponent power for the 27. So we have, and then we've also taken the 2 and moved it up here for the exponent on the log 2 12. We have log 2 12 squared minus log 2 6 plus log 2 27 to the power of 1/3. 27 to the power of 1 cube root. That's where this comes from. Now that we're at this phase, we can start simplifying it down and go step by step. So the next step, take the cube root of 27, which is 3, and then simplify this term, log 6 plus log 2 3. That's your product rule. So log 2 of 6 times 3 is, of course, 18. And then because we're subtracting here in the middle, you're going to divide the two answers. 144 divided by 18 gives us log 2 8, which of course equals 3, because this is 2 to the power of x equals 8. We can also use the law of logs to simplify expressions. You can review over A yourself, but I'm going to talk about B because it comes in with some restrictions on the x variable. So in B, we have these terms log 5 2x minus 2 minus log 5 x squared plus 2x minus 3. So this minus sign tells us divide. We can combine these functions. 2x minus 2 divided by x squared plus 2x minus 3. On the top, you're going to factor out the 2, so divide both terms by 2. You'll be left with 2 times x minus 1. On the bottom, you're going to use the FOIL method and factor out, and you'll be left with x plus 3, x minus 1. Now, if you remember back a few units ago, we had that situation where when we have that common term on the top and bottom that cancel out, that value becomes a restriction to the function. So you would be creating an asymptote at that point. So in this function, it's definitely going to be x is equal to 1. Now, once we've canceled our common terms, we're left with log 5 2 over x plus 3. In this situation, you can't really simplify it any further than this. This is a great expression of your answer, but we want to check using our values that we found and see which statements are true for the values of the log function, so the values in the brackets, or the x plus 3 and x minus 1. So here we have 2x minus 2 is greater than 0, 2x is greater than 2, and x is greater than 1. We know that to be true because x cannot equal 1 up here. And the second logarithm, x squared plus 2x minus 3 is greater than 0. Break it down into its components, and therefore we get x is less than negative 3 or x is greater than 1. So the conditions x is greater than 1 and x is less than minus 3 or x is greater than 1 are both satisfied when x is greater than 1. This means that x needs to be restricted to x is greater than 1, and you create that vertical asymptote if you were to be graphing it. And therefore, when we put the answer, we just say the expression that we originally had is equal to log 5, 2 over x plus 3, where x is greater than 1. So don't forget to consider those asymptotes when you're solving these problems. Look for the solutions where the answer would be undefined. The last type of questions you can have with this section are application questions. So you'll be given a scenario that works with logarithmic functions. The measurement of the volume of sound, or decibels, which you should be familiar with, is a logarithmic function. And we can use the formula provided to solve this question. So we have B, decibels, is equal to 10 log I over IO, where I is the intensity of the sound in watts per meter squared, and IO is 10 to the minus 12 watts per meter squared, corresponding to the faintest sound that can be heard by a person of normal hearing. So in part A, it says audiologists recommend that people should wear hearing protection if the sound level exceeds 85 decibels. That should be like if you go to a Jets game or a concert, you should be wearing hearing protection. Obviously, we're not going to because we're paying for those tickets. But anyway, the sound level of a chainsaw is about 85 decibels. The max volume setting on a portable media player with headphones is about 110. How many times as intense as the sound of the chainsaw is the max volume setting of the portable media player? So in the bottom, there's an explanation of that question. On the right-hand side, there's a decibel scale. You can kind of see what sort of things happen at each volume level. So lawnmower and up, you should be wearing hearing protection. In this question, what we're going to do, we're going to let the decibel levels of the two sounds be B1 and B2. What we're going to do is compare the two intensities. So we know that from the question, we have a decibel level of 110 for the headphones and 85 for the chainsaw. Now, when we have minus the values, then that means we're going to be dividing. So if we simplify and combine these terms, we'll have 10, that's a common factor, it's divided out, times the log of I2 over IO minus the log of I1 over IO. Simplifying further, we're going to divide those two I terms. So I2 over IO divided by I1 over IO. Remember, when you're dividing a fraction by a fraction, you're going to flip and multiply. So notice that the IO comes to the top here in this next step. Now IO divided by IO, that equals 1, so you just cancel them out. And what you'll get as a resulting formula is 10 log of I2 divided by I1. Now you take the values that you know. Keep in mind that your I2 over I1, we actually don't know those values. We're looking for the ratio. How many times greater is the sound in the headphones than the lawnmower? So we have 110 minus 85 is equal to 10 log I2 over I1. And then subtracting those, you get 25 is equal to 10 log 2. You'll divide both sides by 10 to cancel it out, to leave you 2.5 is equal to log I2 over I1. And then you'll get 10 to the power of 2.5 is equal to I2 over I1. And just punch it into your calculator to get approximately 316 times greater is equal to that ratio. In part B, sounds that are at most 100,000 times as intense as a whisper are considered safe, no matter how long or how often you hear them. Sound level of a whisper is about 20 decibels. What sound level in decibels is considered safe no matter how long it lasts? In the previous question, we already determined that b2 minus b1 equals 10 log I2 over I1. And in this circumstance, we have that value of that logarithm, that 100,000 times. So what you end up doing is solving for b2. So we have b2 minus 20 is equal to 10 log 100,000. And then you just simplify from there. And what you get the end result of is 70 decibels. So any sounds that are 70 decibels or less will not cause hearing loss. Beyond this, you have some practice questions that you can complete before class.